Hello and welcome to some more maths with Mr. Thompson, and today it's the first video of your level 3 algebra course, and we start off very nice and simple, but one of the things we want to emphasise at this level is things are getting a bit more formal. We'll be using far more formal mathematical vocabulary, and so we're going to come across things we've seen before, but perhaps speaking about them in a way that may seem a bit unfamiliar. So we'll start off nice and easy. We're going to be doing a lot of work this year with polynomials. Up till now, polynomials have really only looked at things like x squared, unless perhaps we've been differentiating stuff in calculus. But certainly in algebra from this year on, we're looking at cubics and quartics as well, a lot more challenging polynomials. So we should probably get down to what the actual definition of a polynomial is. And it's something that looks like that. It's an expression of the form something x to the power, say 4, plus something else x cubed, plus something else x squared. And I've written it with those C4, C3, C2, C1, and those are the coefficients. So if it was 5x cubed plus 6x squared, 5 would be the coefficient of x cubed and 6 the coefficient of x squared. Okay, so we recognise their coefficients, and of course the actual x parts, those are the variables. So 7x to the power 4, as we see here, 7, 8, negative 10 and 8 are the coefficients, and we have our variables in x. We define a polynomial by its degree, and that's the highest power of x we can see, the highest order of the polynomial. So the one cited above there has degree 4, and these ones I've given you here, of course. If it's just 8x, the degree is 1, x squared has degree 2, a cubic has degree 3. The other terms may be there, they may not be there. It's the highest power defines its degree, okay? And here's something we should know about from before. Polynomials can either be written in expanded form as a sum of terms or expressed as a product of factors. And we'll look a wee bit of expanding here to get us in the mood. So the first sort of challenge for the year is to, how do we expand 3 brackets, okay? So you may have used different methods for expanding double brackets. The method which you should have favoured should be one that will work with triple brackets as well. So this example here, I've taken that third bracket, the x minus 3. I'm just going to park that, leave that alone, and I'll start by expanding these two here. I want to expand those two here the way you learned back in year 10. It's going to give you that first expanded bracket, like that, okay? So when we get that and we simplify it to x squared plus 2x minus 8, what we do now is we take each of the terms in the first bracket and multiply it into each of the term in the second bracket. So x squared goes to x, 2x and then to negative 3, 2x goes to x and then to negative 3, and negative 8 goes to x and then to negative 3. Here's my preferred way of laying it out. Lay out the same order in columns. So put all your x cubes in a little column, put all your x squares in a little column, all your x's, etc., etc. So when you come to gather like terms at the end, all you're doing is adding up the column. Okay, and that's how you expand a triple bracket.